Welcome to Methylene 360. In this video, I want to explain to you how to resolve forces. Now, in the previous video I did on resolution of forces, I did with when you are given an angle and you've been asked to resolve into x component and y component. In other words, rectangular components. However, with this, I want to teach you some other methods or what we most often encounter in problems. So the first one is when you are given the force and the triangle associated with the force. Okay, so let's look at what we have right here. I have a triangle OCB and then I have a force F. So this is the force, this is actual force F. I want to resolve this force along Fx and Fy. However, I was not provided any angle, but then I have this triangle, this small triangle with side ABC. So how am I going to resolve this? So first of all, I'm going to consider triangle OCB. So OCB, all right. Now we have what we call similar triangles. So for similar triangles, I'll say that the hypotenuse of this bigger triangle, which is F, divided by the hypotenuse of the smaller triangle, which is A, should be equal to the horizontal side of this bigger triangle, which is Fx, divided by the horizontal side of this triangle, which is B, which should also be equal to the vertical side of this bigger triangle, which is Fy, divided by the vertical side of this triangle, which is C, the small triangle. Now, then I can say that Fx is what? F. So if I make Fx the subject from here, Fx is going to be F into B divided by A. Similarly, Fy is going to be F times C divided by A. Now, using the unit vector approach, I have a force Fx along the I, then I have a force Fy along the J. In fact, the I and J represent the unit vectors along the I, the X and the Y components respectively. So this is how I can do this in the unit vector form. Finally, using Pythagoras theorem, I can say that F squared equals Fx squared plus Fy squared. Okay, let's look at resolution of forces on oblique axis. So sometimes we encounter axes which are not perpendicular to each other, just like the rectangular component. For such axes, we cannot use our trigonometric ratios to resolve the force into F cos theta or F sin theta. Okay. Rather, what we do is that we draw a parallelogram to contain the force and we use the sine rule. Okay, so let's consider the force system. So I have this force like this, F1 with an angle theta. This U and V are not perpendicular to each other, so I cannot use the system of rectangular components, so I cannot use sine theta cos theta here. Similarly, as this force F2 making an angle beta with the U axis. So what I will do is that I'll draw a parallelogram to contain the force, then the component of the force along the V becomes F1 V. Similarly, I have U, so F1 U along the U direction. Okay, similarly, I'll draw a parallelogram around F2. Then I will resolve it into F2U along the U axis, and then I have F2V along the V axis. So let's say that these angles will come from the geometry. Now, using the sine rule, I can say that F2 divided by sine alpha should be equal to F2V divided by sine beta should be equal to F2U divided by sine phi. Take notice that all these angles must be opposite to the side of interest. And so F2, this is F2. The angle opposite to F2 is alpha. This is F2V, and the angle opposite to F2V is beta. Similarly, this is F2U, and the angle opposite to F2U is phi. I'll do the same thing to F1, and I can say that F1 divided by sine gamma equals F1V divided by sine theta should be equal to F1U divided by sine chi. As a matter of fact, the same thing. So F1 is here, the opposite angle is gamma. F1U is here, the opposite angle is chi. And then F1V is here, the opposite angle is theta. So this is how to resolve a force into coordinates which are not perpendicular to each other. In other words, oblique axis. Now lastly, let's look at when I'm given a unit vector. So a force and then a unit vector along the force. So one thing that we must take notice is that whenever I have a scalar quantity, I can get a vector quantity by multiplying a unit vector by the scalar. So this is what we are saying. I have a force F and then I have A and B. So A and B are points, with the starting of the force to the end of the force. So we want to describe position vectors. So dx, di, dx along the x, dx, dy, dx along the x, dy along the y direction. And so a unit vector is what? A vector divided by its magnitude. So I'll walk from A to B along the x and y, and I'll describe a unit vector. And so this is the unit vector along AB. So I will multiply this unit vector by f. And so in other words, I will separate this into f multiplied by dx in the I divided by d. Now this d is actually the magnitude. And then I'll multiply f by dy divided by d. Alright. So we are saying that this d here represents the magnitude, that is to say dx squared plus dy squared. Then I've been able to resolve this force into x component and then y component. So this is how to resolve this kind of forces. Depending on the nature of the problem, you would know what to do. Thank you for watching.